Dan Carey here with from Robotics Trends and Robotics Business Review. This afternoon we're interviewing Patrick Rowe, who's VP of R&D for Pittsburgh-based RE2s. Maybe you could describe some of the more recent projects or recent SBIR or other contract wins that you had for your technology.
Probably our most mature product is what we call automatic, and that is a 4-degree of freedom manipulator that has automatic tool change. So the robot, you can think of the robot as carrying a tool belt with it of different tools such as grippers, knives, drills, and so forth. The operator says, I want tool number 2, and the robot automatically puts down whatever tool it's currently holding and picks up the new tool, and the operator can then proceed with their job.
And who are you doing that work for?
That is with the Office of Naval Research and the Naval EOD Technology Division.
Okay. And do you have any idea what the final use for this particular technology, or what they're envisioning the final use would be?
The initial use is for EOD and bomb disposal, but they're also interested in things like surveillance, like getting access to vehicles, suspicious vehicles, to insert a fiber scope to look around. And so that we're seeing some opportunities there in terms of different types of tools, different types of sensors, such as chemical, biological, radiation sensors that can be put on the end of these arms. And then the operator can pick whatever tools that he or she needs for the current job, and the robot can carry them all down with them.
So it sounds like just we're moving into the next generation of these types of systems. In the past, or at least for the first 5 or 6 years of the Iraq War, they're fairly simple in terms of one arm, or they might be able to look around and do some other things, or even place explosives. But now, more complex operations, would that be fair to say that?
Yeah, and that's really where the intelligence comes in with the intelligent modular manipulation. Right now, currently fielded robot arms are still quite primitive. Each joint is controlled individually using knobs or switches. We're putting more intelligence in the arm to get easier control for the operator. For example, the ability to fly the tool around just in the same way we think about moving our hand in space. You're not actually thinking about moving each joint individually, you're thinking about where you want to place the tool. And so we're adding that intelligence into our robotic manipulation.
And the software component of all that, is that your own development?
That is our own development, yes.
And let me ask about the mobile base itself. What mobile base are you using for this particular device?
We've designed our arms to be used on really any mobile base that have the size and weight capabilities. We've worked with companies like iRobot, with Kinetic NA, and with Remote Tech to add our robotic arm technology onto their platforms.
Interesting. Do you have any other initiatives underway with respect to manipulation?
We do. We're currently completing another Phase 2 SBIR where we're looking into highly dexterous manipulation, 8-degree of freedom arms. We have a project with Tatrick where we're looking into heavy lift electromechanical manipulation, being able to lift over 300 pounds.
We saw, when we were walking through your offices, you had a mobile unit. Can you describe that mobile unit for us, and what's that all about?
Mm-hmm. The mobile unit is another result of a Phase 2 SBIR. We call it Forerunner. It's a all-wheel drive, all-wheel steerable ground robotic vehicle, and it was designed to go very high speeds, up to 25 miles an hour, for a vehicle which is about 3 feet long. Because of that, a lot of work went into a nice suspension system. It also has the ability to carry about 30 pounds of payload, so we have a small robotic arm on it as well as some cameras. And it's really meant to be controllable at all speeds, so at very high speeds it's controlled like a race car, and at very low speeds, because all the wheels are independently steerable, it can be used to turn in place. And so we see it as being used as just another general vehicle platform that payloads can be put on for EOD missions, for reconnaissance and surveillance missions, and the like.
Interesting. I had some questions in terms of other types of technologies or that you might be interested in. We talked about partnerships, and in fact you might be looking at them. What are the areas that you see in terms of technologies where you think that RE2s might be interested in the future? Maybe not whole cloth products, but just specific technologies, whether you're looking for those technologies in terms of you needed to move ahead with certain initiatives, or you in fact might develop that technology yourself. So areas of hot technology.
Well, I think one of the areas of hot technology we're starting to investigate in-house, which goes with the intelligence of manipulation, is now making the arms more self-drivable. So putting in sensors that allow an operator to, the end goal is to present a camera image to the operator, for example, have the operator use his or her mouse to point and click on an object in that image, and have the manipulator automatically go and pick that up for them. That is the ultimate end goal that we're pursuing in terms of increasing the intelligence of our manipulators.
Okay. So what's lacking there might be in terms of touch sensors and smart software. So it seems as though the cameras and actually the motors and the gearing, all that's there already.
Yeah, in terms of cameras, of course, we're always looking for sensors that are very small, that can fit into, say, the palm of the gripper. We're looking into sensors that can provide force feedback, so you know how strongly you're handling an object, as well as looking into very small depth sensors. One of the big problems we know with trying to manipulate or use a manipulator through a camera image is you have very little to no depth perception. So the operator really doesn't know how far away the gripper is from the object of interest. And so having just a measure of the distance from the gripper to an object would be a huge benefit to operators today.
There's no way to do that with multiple cameras?
There is a way to do that with multiple for example, stereo cameras. In that sense, you start getting into very advanced processing. You need a lot of processing power. So we're always concerned with simplicity and with cost.
I want to thank Patrick Rowe, who is the Director of Research and Development for RE2s. Thank you very much, Patrick.
Thank you.